Hi, this is the Prakash Inturi, the Director of Dino PTS Design and Engineering Solution, Visakhapatnam. In this session, we discussed about rectangular hollow flange beam with web opening. Is a steel structure we are doing in abaqus. Okay, here see it. It is a model of the steel structure. Uh, these are the opening web and the rectangular flange and web and flange is connected with the 8 boards. Okay, same object, but here the flange, another bottom flange, we are making it another direction, opposite to the and in the image. I will open the abaqus software. The abaqus CAE. Here, I already created the model. It is a model. You can see that. It is a model. Here, it is a 200 support. It is a 200 support, as well as it is a 200 and one object we place it at the on the flange to apply the load. Okay, for that, in the parts we have created at the different parts. We can see that the one is it is a support. It is a rigid member we are simply are taking. It is a rigid member, and one center node we are assigning is a reference point because to apply the support, if you are applying the at a reference point, entire support assigning to the entire plate. So, and it is a support plate, and the middle web is middle web, and next one is here. It is a top flange, and the same this flange also used for the bottom also. Okay, and the next one is a thick plate to support the web at the center level. Okay, here I will show the assembly model of this one. Here it is a support plate, and the load is applied from here. And next one is it is a bottom flange, and it is upper flange, and it is a web, and it is a 200. Sorry, it is a 20 thick the plate, like to restrain the vertical displacement at the center of the particular steel structure. Okay, here for this one, I used the materials like the plastic character also included. For that, these are the material we are taking from ferrous 450 material and elastic character and the density also. The here the entire model we are doing in millimeters. Okay, and the next one is the section here in the section. It is a shell type of model. So shell thickness we have taken as a 2 and as well as at the middle of the section is there, we have taken as a, sorry, it's not a 20, it's a 10 thickness of the center. Okay, these are the two cross sections we have taken. And next one is we are going to assembly. We can see that assembly. And next one is the step. For this step, we have taken the dynamic explicit character, and the time is 0.1 second to apply the certain load at the from the at here as a reference point. And the next one is the iterations. We have given the iteration for that bolting for flange and web. We have used the fastened. there is a option is create connector sections is there and fasteners. Here the fasteners we are assigned with 8 mm beam element. And next one is at the bottom one and top one also, as well as the some fasteners are assigned to the and the base plate also. Okay, next one here at certain portion of web, sorry, certain portion of the flange is directly connected, surface connection is we have provided at the bottom and at here is also and at here is also to avoid the slipping motions and like that. And here the coefficient of friction 0.3 is used like that. And the next one is here. The meshing has provided to get a proper meshing, and at the same time we have provided for to get a fine mesh around the fillet region of the model also. Okay, done. And the next one is the loading we assign it. In the loading, we have taken the three types of loads, and at here is all degree of constrained, and at here is also all degree of constrained. And the next one is at here we have given the displacement 40 mm and towards the y direction. This is the 40 mm is the ultimate displacement in the experimental, and the random here loading support also given at 0 second is a 0 and point 1 second it is a 1 displacement we have given. Okay, done. It is completed, and next one we have to find out in experimentally at displacement gauge we are provided at here and at the right side and the left side, and which is like longitudinally, as well as the transfer direction also at here we provided. Displacement at here, the middle of the flange. So we are creating at here. So initially we are performing the simulation. One at same time it is a reaction RP and it is a reaction if the RP is there. We can get the reaction also. For that, initially tools and set. Here we are creating the create. The set number is what is one here reaction RE1 reaction 1. Okay, let us give the capital letter RE1 reaction 1. Sorry, yes, RE1 RE1 and the geometry and the select. This is the part is RE1. Okay, and at here we are getting the reaction load as well as the tools and the set and create at here RE2 reaction 2 and okay, it is a point of reaction 2 and okay, as well as the and it is a point we are considering the displacement also. So to go to the setup and the historical data we have to record. So we are going to historical data and set to and choose this set. In the set here RE1 reaction 1. In the reaction 1, the forces and reactions is there in that forces and towards the it is a y direction. So it is a y direction. So y direction reaction forces we have to collect it here. And the next one is add and okay and choose this set at here and choose the which one it is a which one reaction to and the one reaction forces sorry okay at here set to reaction forces and reaction forces 2 and okay, this is the data we are collected. And the next one is we are performing the simulation job and okay, and here the submit and okay, automatically software will solve the problem. It is a shell type of model. So and here less number of elements and at the same time if you use the shell element within short time we can solve the problem so that we use the shell element. And if we go to the monitor, we can analyze the load steps increments. Half of time reached. Yeah, we are reaching to 0.09 second. And the next one, yeah, with the last iteration, it will finish. It is a solution is done successfully and close. Let us check the contour plots of the results, and here we can see the displacement for the number. Okay, and how the flange rectangular flange of open web structure, how the going on, you can see that. And at the same time, animation also we can do it. If you are applying the load, how the displacement is going on, we can see with respect to the time. Okay. And the next one is so we can off the all the edges and okay, can see that clearly the structure, how it is responded. Okay, the structure. Now, want to create the displacement versus reaction load. Let us check the reaction. Just click on here, and there is an option is ODB history output is there. Okay, there is a see that here the one which one here reaction force and RE1, RE2. And here some first half of reaction force comes here and another half of reaction force comes here so that we have to joining the two reaction force. Okay, how is going on? Let us check that initially there is a click reaction one and save as and off it. It is a one is RE1 reaction one. We are saving as the reaction one and select one and save as here the RE2 reaction two and okay reaction one and reaction two. Let us go to the operate exploit data. And, we have a two options is there, and now we have to uh, sum sum the data. So there is a sum is there, sum and reaction force, and this is the reaction force, and here is save as it is a data is final reaction force RF final reaction force and okay. It is the reaction force. We joined the reaction. So let us check that reaction force, how the reaction force and plot. We can see that it is a reaction force of the structure. It is a positive value. Okay, and now we have to create the again the displacement. The one now we have to take the data from here there is a, and just click on the ODB result from field output and okay, in that here there is a element and nodes is there and integral point to unique model. In that unique model, we have to take the which one there is a spatial displacement towards the y direction. And longitudinal displacement to collect. So we are going to here and pick from view. In that pick from view and node set, just we are going to the mesh. Here, yeah, sorry, is a visualization. In the visualization, see that Unity node that you to is the label and pick from you and okay select the any node on the plan. Let us check that is it selected at proper location or no. Here it is the one. Let us check that okay it is almost the location. You can see that it is a location. So here it is a data we have given and done. It is a node one is selected and save as. It is a data should be and save as here. Save as. Okay. It is a displacement we have given and just close it again here and history output. If you go to the history output, there is a spatial displacement is there. Let us check the spatial displacement. it's not come. Okay, let us check it. Yeah, yes. There is a spatial displacement at a node is the one. Let us check this is the plot is toward the minus direction. So it is a displacement is going on uh, downward direction. So we have to generate the displacement versus load plot. For that, they operate XY data and okay. Now there is a combine is there. Here the combine and is for the combine and a minus of displacement and at the same time reaction load. And here they save as this one is displacement versus reaction force. And okay, this displacement and reaction force and close it here. If you go to here, the displacement versus reaction force, and it is a information related to which one here the displacement and that reaction force. Braking is completely here. We can see that this is a plot for displacement and reaction. Okay. Uh, Due to some movement, there is a it goes to the displacement small negative value, and we can control the displacement external. Okay, it is a very good project for civil engineering students as well as the professionals. This video very uh, thank you.